Hi. Today, we're going to talk about leveraging open source software for flexible API observability with Kong and Moesif. Just quick context on who I am. I'm the CEO of Moesif, the leading API observability and monetization platform. And we love working with API first businesses around their API strategy and improving their API experience and building better API products. You can find me in San Francisco. My email there is derek@mosif.com. What are we going to be talking about today? Well, first, we're going to walk through some of the common issues that we're seeing with these newer AI APIs and applications. We'll walk through AI usage observability. What does that mean and how to get it set up? And we'll walk through the Kong most of integration itself. And lastly, a quick demo around optimizing AI usage and having a good understanding around that usage. Well, why is this talk relevant today? And we're not chatting about this a couple years ago. But the biggest thing is the way that software is consumed is dramatically different. Previously, most SaaS-based applications, it was normally a user would log in, and most of the interactions with the SaaS application was predictable. They'll click here, open up a drop down, maybe go through a particular wizard, but a lot of the interactions were predictable and also following predefined use cases. These use cases that the product owner already thought up, and so you can think of them as canned workflows. But as we move over into this AI age, these different AI agents are really have a mind of their own, right? And they can start going down different paths that were really never thought of before by a product owner. And so what's happening is you're going to have different and very large variances in usage. One AI agent may use very little of your AI APIs, and another one might have a lot of usage. And the queries themselves are very, very dynamic in nature, right? So it's actually hard to have a good understanding of predictability across the different queries. And so when you have this uncontrolled AI usage, it can be very disruptive for your business. And the first thing is this, how do you actually stay compliant with performance SLAs, reliability SLAs? Traditionally, we look at things like duration of an API call or number of 500 errors and what percentiles of those 500 errors and everything else. But when we look at AI queries, given that they're very dynamic, not now you really can't look at those 500 errors or anything else because in this case, you could actually have a bunch of AI queries returning 200s to the client, but the result is gibberish. It doesn't make any sense. And so, does that mean you're meeting the SLAs when the results themselves is gibberish? And then you have things like the real costs. Becomes unpredictable. And so that usage can vary dramatically from what you initially estimated for cost. A lot of this is due to uh, now you're using and depending on an LLM, which is now charging in terms of input tokens and output tokens. Previously, when you're building out a SaaS-based application, you have a good understanding of a VM costs X and you need 100 VMs, and so it's a relatively static cost that you need to consider. And so this is now introducing a lot of variability into your cost profile of your application. And lastly, these AI APIs are providing direct access to a lot of data, a lot of sensitive data at your organization. And so this can actually open you up to both privacy issues, but also economic abuse, right? Because these AI APIs are depending on third-party LLMs like OpenAI. And so if a bad actor, they could actually leverage your AI API and there's arbitrage opportunities there, right? Because they could actually increase their own usage, which would have a direct impact to your own cost as well. And when we start thinking about AI usage, there's a lot of different dimensions to consider. Everything from input token counts, output token counts, model versions, everything else. So you have this n-dimensional, data set to meter and track. But this is on top of the original dimensions, that we would normally look at as well, such as the application and environment and user and everything else. And so we're a big recommender of having centralized AI observability, right? And so that means having a way to measure, and track this AI usage in real time. And this could be across different APIs and models. But a big thing is also to tie this usage data to revenue data. So that way you have a good understanding of both operational level observability, tying it to business level observability, which gives you context around cost and revenue and everything else, and how does that correlate to your performance metrics. And so that's where tagging and attributing this data to different consumers, to different use cases, departments can be super helpful for tracking that cost and performance and those metrics. And lastly, having a way to detect different usage patterns, when someone does have a big spike in usage. One of the biggest issues is today's metrics are more focused around infrastructure, right? And so we look at things like memory, latency, errors per minute, but you could have an AI API, very small number of requests per minute, but suddenly there's a big spike in token counts or big spike in the amount of data going over the wire. And so you have to go a couple layers deeper to really understand, the performance and reliability of these AI APIs. Just looking at vanity metrics like requests per minute and errors per minute is not enough to really give you the right insights. And so when we think about metrics, it's looking at things like model accuracy. Potentially, a smaller model can be used, which will reduce cost and improve performance without impacting accuracy that much. And also looking at usage by user, by different applications, and this can give you insights into potential abuse, whether it's unintentional or intentional. These AI APIs are still relatively new, and users are still creating new use cases by the day, and so a lot of these clients are not going to be, efficient in terms of the usage of the APIs. And so identifying those users and working with them to make their usage more efficient can be helpful for both parties. And then lastly, also, of course, tracking the outcomes themselves. Is it relevant for the prompt that was issued? Is it garbage output or was it garbage input? Because you could have a user that actually issued maybe 10 different requests against your AI API. And the only reason why there was 10 different requests was because the first nine were not relevant. And so the prompt was repeated over and over in a different way. And so measuring that and identifying these repeated prompts or less relevant prompts can be helpful for tracking success. And so there's the Kong and Moesif plugin. So this is an open source Apache 2 licensed plugin that is available for Kong. It works with Kong open source, but it's also validated against Kong Enterprise and Kong Connect. And that enables you to effectively mirror the API traffic, which is then logged to the Moesif platform. And so now we're going to walk through a demo of what it looks like to set up and then walk through the Moesif platform itself. On the setup process, it's relatively simple. So it's just a matter of installing the Lua Rock package, which is available, or the Lua package, which is available on Lua Rocks. And then you enable the Moesif plugin itself by modifying your Kong config file. You restart, and then you enable the plugin. You can pass in a set of parameters as needed, which I'll walk through in a second here. And that's it. Once you do a last restart, you should start seeing that traffic flow into Moesif. One key thing to think about is identifying users. So going back to what I mentioned is it's important to track this AI usage and attributing it to certain user accounts or consumers to understand costs and performance profiles. By default, this plugin is going to attribute usage to a Kong consumer ID, but you can tweak this, as needed. So, for example, if you have JWT in your authorization header, you can pull out the subject and use that as a user ID as well. Jumping into the dashboard itself, these are, of course, drag and drop dashboards that you can modify as needed for your requirements. I have a couple of metrics I'm looking at here, which is embedded API growth rate broken down by different customers, daily active users over weekly active users, some product metrics. Then we also have things like input token count and a few others. So let's say we want to actually go ahead and build a report. And I just want to understand, what are my top consumers? How much usage do they have in terms of my AI API? So I'm gonna go ahead and jump into segmentation here. We're gonna actually do a group by company domain. So top 10, I'm gonna switch this to table view. And right now we're just looking at event count. So event count is number of API calls, which is okay. It's one thing to look at API calls, but it'd be more helpful to see the exact input token counts for each of these customers. So I'm going to go ahead and add number of input used. And now we can actually see that metric shown as well. But more importantly, we might want to see which customers are using a high number of input tokens relative to the number of API calls that they're making. And so we can go ahead and add a formula here. We'll go ahead and do B divided by A. And let's add a name to this too. So the inputs tokens per call. And we sort this, we'll see that looks like Lawrence Darkly followed by MongoDB are using on average the most input tokens per API call. And so this is a way for us to actually track that consumption broken down by different customers. And we can, of course, slice and dice this by different parameters besides company domain. And we go ahead and, if we have other parameters around, such as model, we can go ahead and do that. Let's just go ahead and add a model, and we can again see those API calls. Now, let's say we want to actually look at maybe the performance of the different models that are being used. So I'm going to go ahead and uh, zoom out a little bit. Let's look at the last 28 days here on a daily basis. And right now, we're still looking at event count. So let's go ahead and switch this to, say, duration. So right now, I'm just looking at API call duration. We'll do percentiles. So we're just looking at the 95th percentile across all of the traffic that we see in this account. And we want to look at potentially this same latency metric broken down by the different models. And so here we can see on average it's around 300 milliseconds. Don't really see any anomalous behavior other than looks like GPT-4 and GPT 3.5 Turbo looks like around May 12th. There's a little bit of a spike there. And we can even ask AI to summarize this further. It does take a few seconds. This is using Azure OpenAI underneath the hood. And if we want to get alerts on this, we just go ahead and click the alert button, and that will give us the capability to route an alert to, say, whatever alerting systems are using internally. So just going back to the rest of the demo here, or rest of the deck, as a recap, key thing is to make sure you have the right API observability, but also the right governance best practices in place. And this means enforcing strict quotas and governance, which helps you prevent usage spikes from causing massive cost overruns. And worst thing that happens is someone deploys an update at 2 in the morning and suddenly you burn through $10,000 in credits for OpenAI or other AI APIs. And so getting the right monitoring and reporting can be helpful to detect this and notify the relevant parties. But it also means requiring periodic audits so you can find those applications and consumers that potentially are having an impact on performance and cost. And we can set up rules automatically so that you don't have to wake up 2 in the morning for those type of issues, and that can be actually handled by the Kong and Moesif plugin. And this can be done through different policies. For example, we can actually set up a rule to block, say when it's in this case when someone runs into zero prepaid balance, we can actually give them a message. You ran out of credits. And again, this can be helpful to protect your infrastructure before things are uncontrolled in terms of usage, especially if you're experimenting with new AI APIs and they're not even revenue generating yet. It's important to make sure you keep the cost under control. And then once that's done, of course, we can go ahead and send out emails and stuff to the relevant parties to let them know they have been blocked. My email here is derek@moso.com. If you have any other questions around how to think about API observability for your AI APIs, let me know. We've definitely been seeing a lot of different use cases and happy to share any tips and guidance around this topic. Thank you very much.